Okay, good. I think I finished up to here. That what is the biosensor, and I think you have understood, right? What is the definition of biosensor? Hmm? Hmm? Right?
Yes, sir. Yes.
It is clear,
Yes,
right?
sir.
And why we have so many different kind of sensing method like electrochemical, calorimetry, mass thermometry. So among all the methods, so we are interested in this class, the electrochemical biosensor, because it is very much simple, sensitive, easy to miniaturize and affordable. So basically we are interested to develop a point of care device, right? So, and for the point of care sensing, biosensing development, so this four you have to very much keep in mind these four topic, this 4 point. One is the simple. It means your detection technique should be very simple. It should be very much sensitive. Why we need sensitive? So we need this. We need the sensitive technique because we want to detect the biomarker, the very low level or early detection is very much important, right? So that's why sensitivity is very much important. Then easy to miniaturize, because if we can miniaturize easily, then only we can bring this device to the near patient. That's why miniaturization is very much important. Not the bulky. We don't want to depend the bulky instrument, right? And affordability is very much important also. If you want to, if you think like developing countries or who are underdeveloped, so for that, I mean the cost of this sensing device should be affordable. I mean, they should afford. Otherwise, our science will be only inside the laboratory, not in the, I mean, not for the patient, right? So that always we are thinking how we can bring your technology, your science into the for mankind, right? This is the main important thing for this class. How you can bring the science, your technology for mankind. So now I'm going to show you a very basic, very interesting video. Here actually you can understand what is the biosensor meaning and what is the common sensor methodology we have right now in the market. And and means 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 how, from the beginning you have to think how you can bring your technology in the market. That is our ultimate goal. Okay? This is very much true that although we are thinking so many technologies, so many sciences, but they are not in the market, right? If you see right now, only very few innovations are here. Why not others? Every day, so many, I mean, millions of inventions already scientists they are creating. We are publishing many journals, right? But still there is some drawback, or something we are not achieving actually. That's why our technology is not in the market. That you have to understand first. So just see very simple technology, how the biosensor can help your innovation to the market. I think you are very much familiar with this glucometer, right? So let's see this video. You can enjoy this so that you can understand from your common sense, your day-to-day life, what is the biosensor. Please see this one.
A molecular biosensor is a compact device that measures specific molecules for informing us about health and disease. The measured molecules are called biomarkers.
Is it audible to everyone? Everything fine? The video?
Yes, sir. So,
Yes, sir. Yes, sir. Yes, sir.
Okay, let's start. Let's understand what is the biosensors and what is the target, what is the bioreceptor. I already taught you, right, last class. What is the bioreceptor, what is the target, what is the transducer. So all the things we can integrate to a biosensor, right? Let's see.
Sensor operates on a sample taken from the body, for example, a drop of blood. or it can be worn on or inside the body for giving continuous measurements. The most well-known biosensor is the glucose sensor, which measures the concentration of glucose in the blood or in the skin. This is very helpful for patients with diabetes. With a biosensor, patients and doctors immediately get the information they need in order to optimize treatment, reduce unnecessary hospital visits, and enable self-management of health and disease. A biosensor consists of 4 major components: a molecular recognition process, a signal generation process, a disposable sensor device, and a reader instrument. Recognition molecules in the biosensor bind to the biomarkers. The recognition molecules are, for example, aptamers, enzymes, or antibodies. The molecular recognition leads to a signal, for example, an optical, electronic, or magnetic signal. All this happens inside a disposable sensor device where the molecules come together. Finally, the reader instrument measures the signal and translates it into information that is meaningful for the user. There are many diseases and many biomarkers, each having different measurement requirements. Also, there are many technological ways how a biosensor can be designed. That's why Census was found.
Yes. So that's the story. Actually, the biosensor that is currently available, like the glucometer, that is the things that I already taught you in here in this class. So see, like antibodies, peptide, aptamer, they kind of bioreceptor that can be immobilized on the transducer surface. Then we can target, means we can detect our analyte, right? So the transducer, they can help us transform your one form to another signal, right? This is just a transducer that can transform your one energy form to another form. Maybe some chemical energy, they can transform to the maybe some current, right? Something like this. So you can get, and by using a mobile device like your smartphone, we can see the digital value, how much biomarker present in the blood samples, right? So this is the whole story of the biomarker, of the biosensor, right? So you have to just keep in mind that biosensor, it is kind of device, right? And it is very much specific, right? So biosensor always specifically detect the target analyte. If it is not specific, it is not the biosensor. Okay. Now come to the biosensors that. Yes. If you have a question, please ask.
Sir, was it? Was that glucometer remote device? What was the white structure on a skin in the video?
Oh, on skin white structure, see, yes. So I can show you like it kind of the real-time monitoring of the glucose that I'm going to teach you today. So on skin, you can develop a patch type, like patch type or kind of these things. You can develop like skin printable, some sensor on your skin. So they can real-time, they can monitor the glucose and they can send the information wirelessly to your mobile device. So every time you will get the information within after 1 hour, with 1 hour in interval, they can send you the data. Accordingly, we can take the decision like this. Maybe sometimes we need the insulin pump, so they can, based on your glucose level, you can use the insulin, kind of this. Specifically, who are the diabetic persons. For that, this real-time monitoring is very much important. So for that purpose, we are using some portable, some patch type biosensor on skin. That I will teach you today. This kind of modern technology. Okay, clear?
Okay, sir.
It's very interesting. Some very modern technology we can see here. See here, like that's a very good question you asked. And here also see on screen. See, this is kind of tattoo, right? We printed our sensor. So here actually this is the biosensor here. So they can sense like different kind of analyte from the sweat sample, or maybe sometime it can detect as from interstitial fluid just under the skin. We can get the interstitial fluid and they can sense the level of glucose, uric acid, or some kind of analyte, metabolite, kind of analyte you can detect. So based on your technology, based on your design, see, I am going to guide you actually. Basically, see, this class actually I am guiding you some very generic sensor. So you can think only can I use this one for glucose? No, means I'm just giving you the technology you can use for any kind of biomarker. So just take it and you can apply this method for your future. So this is kind of a one new method, new technology. I think you already know this pregnancy test kit that is already available in the market. So this is a kind of the portable and very simple device. It is kind of the colorimetric. If you see color, then you can say it is positive, or if you don't see, then it is not. It is negative, something like this. So this is the glucometer. You know, very simple method that you have to prick the finger, just from the one drop of blood. You can get the value. See 102. So like this much. I mean, this is a very kind of a user friendly, right? You don't have to depend from doctors. So you just you can prick your finger, you can drop and can see the value. So this is the main goal, our final goal, how we can make this kind of user friendly device. So maybe so generally, if you see the actual development of sensor, sometimes we may need this different kind of washing method. See, this is maybe your sensor, right? So here you have all the chemicals, all the chemicals. So now you are dropping your sample. So your sample will react with this. Then if you think about the lab based, so what the lab technician, how they are detecting. So they will modify your surface. Then they drop the sample. They will wash the surface. They will connect this one with a device. Maybe there is some other manual method there, right? So for that we need some special person or some expert person for this. But here you see nothing. We don't need any kind of expert person. So just drop, and there is some microfluidic channel there. So they start working. They immediately can start working. So reaction will be started. So now I mean this signal will come to your device, and there is some app there, right? So maybe some mathematical algorithm there. So they will start functioning, and they can show you the exact value. Basically user they're not doing much thing, just they have to drop the sample, they have to wait for it. It's depend on sensing method and which biomarker you are going to detect. Sensor to sensor depend how much you have to wait for your result. If for the glucose, it is very immediate things. I mean, just after dropping, immediately within a 30 second, you may see the result. But some sensor, you may have to wait for 10 minutes. So based on your technology you are developing, that is for waiting time. Right hand side, you can see this is the actual electrochemical chip. This is the main chip that we are inserting with this device. So this chip basically, see here some part. Generally, end user they can't see these things. That generally we cover all the part. Only this part open. They are dropping the sample. But this is the actually working part. This middle circle one. This is the working part. This is called the working electrode. So we are now interested in electrochemical sensor. That's why I always mention the electrode. So why we need electrode? Because this kind of area we will immobilize our bioreceptor that I already mentioned in my last class. Like bioreceptor will immobilize. It may be antibody, it may be enzyme. That will help to bind with the target, or maybe it will start reaction with the target. Then it will give the signal, and it will start generation electron, this kind of thing. Then it will go through your counter electrode, and then you will get the signal with your. You can see in your portable device. So here, three kind of electrode you can see in your electrochemical chip that I will again teach you in details later. But first, I want to show you what kind of chip we are using for the electrochemical biosensor. So this is the whole electrochemical biosensor chip. One is the working electrode, another is the counter electrode, and last one we are going to use a reference electrode. So the material, everything I will teach you later. But today just I want to show you the three part of the electrode: working, counter, and the reference. So working area, we will immobilize our bioreceptor. It may be antibody, maybe enzyme, maybe aptamer, we will immobilize here. In the counter electrode, they will help to transfer the signal from your chip to your device. That will help. So this is the counter electrode. Reference electrode, actually on best reference, it has its own reference, some potential. Reference electrode, it has your own potential. Suppose it has like 0.1 volt, its own potential, right? So by this device, I mean, we have to like press a button, right? So if we press this button, so immediately, so it will get some potential, right? Some potential will apply basically on this chip. So that potential will be respect to this reference electrode. So this is the standard one. With respect to this, we'll apply some potential. Then some reaction will be starting here, and based on this reaction, counter electrode will help to send all the electron to your device, and we will see the electrochemical signal. This is the main things. I am telling today very simply, but you may have so many questions, that all the questions will be addressed when I will teach you very detailed way all the material, what kind of material we can choose for working electrode, for reference electrode, for counter electrode. So these things I will discuss again. When you will have maybe so many questions, that time I will address all the questions. See now. So actually this biosensor area is a very, very exciting topic, and worldwide people are very much interested in this area, biosensor. If you see here, actually worldwide biosensor is a huge market. So yearly, actually this investment, if you think the company to company, so people actually investing lots of money in this area. They wanted to see some kind of physical device in the market, so that at least we can detect the disease at the early stage, and we can save the patient life. People are investing worldwide lots of money in this area. And if you see the research, if you think about the research, so worldwide, if you see biosensor publications also is increasing rapidly, exponentially. So I think if you go back few decades before, I think people at that time not much interested, but currently you see many publications in this area, because this is a very exciting area. On this, based on this sensing, we can solve many problems, especially in the diagnosis, especially in the medical area, medical purpose. So now, see in this slide, now as I mentioned, that people are interested so many other technique, like optical mask, like different technique they are interested. But electrochemical, as I mentioned, it is very simple, sensitive, easily miniaturized. That's why people are very much interested in the electrochemical area. So if you see the black bar, so compared to other technique, actually electrochemical technique actually very much interesting area. Now come to the challenges. Recently we are facing kind of challenges. So in the medical diagnosis and healthcare, so generally we are focusing three main points. One is the quick detection, two is the on-site detection, and three is the ultra-sensitive detection. So why these three? See, generally, if you think like a development, some device, and if you have to wait for a few hours, maybe sometime a day, that may not be useful for point of care device. And sometimes people actually don't rely on this kind of device if you have to wait for a long time. Sometimes we have to detect some disease very quickly to save the patient life, especially during the operation theater. The operation theater, during the operation, different kind of major surgery. So this we have to depend on such kind of device that can give a quick result. So that you have to keep in mind. Another thing, the on-site. Always we cannot send your sample to the diagnostic center, wait and then wait for their data, then we can go for the diagnosis or go for their treatment. That may not possible always. So if you can develop something on site, immediately near patient you can detect, that will be the most interesting and most innovative. It can be helpful to save the patient life. And last point is the ultra sensitivity. Okay, so why ultra sensitivity? That I already mentioned, because we have to detect there is some threshold level. Maybe the healthy zone, and upside is the, I mean, for the non-healthy. I mean, healthy zone, they have maybe some level of the analyte. Always you have some maybe analyte. Let's see the, like the diabetic patient, you have some glucose level, right? Maybe 102. This is your glucose level. So your sensor sensitivity should at least if I mean, you cannot detect the healthy level of the glucose. Same thing like for the cancer. And sometimes your cancer biomarker, like a prostate specific antigen. One, this is for prostate cancer. Suppose your prostate specific antigen concentration is 1 femtogram per ml. So you know, femtogram is a very, very low concentration. So nanogram means 10 to the power minus 9, right? Microgram means 10 to the minus 6. Micro, nano, then 10 to the minus 12 is the femto. So, sorry, so this is nano, then 10 to the minus 12 is the pico, right? This is pico.
So 10 to the power minus 15 is femto, right?
Yes, 10 to the minus 12 is the pico. Then 10 to the minus 15 is the femto. So this is the very, very low level. So suppose you have the 1 femtogram per ml, right? It's very, very low level. So in this case, if your sensor sensitivity is not that much, so then you cannot sense the healthy level, right? So if more than 1 femto, like 10 femto, if you have, if your sensor cannot detect this much, then your sensor is that much, not that much sensitive to give you the information so that you can go to doctor and you can go for the proper treatment. So that's why ultra sensitivity means, why I mentioned the ultra sensitive this point, because this is very, very low level. It is actually very ultra sensitive point, right? So that's why your sensor should detect that much, very, very low level. But what is the answer right now currently? So if you see the current market, if you go, there is very limited number of devices available, not for all the disease marker, not all for the cancer marker. If you think like recently, like COVID case, there is not lots of kind of the devices available so that they can help you to detect the COVID disease, at least SARS-CoV-2, right? At the very low level or very early stage, they cannot predict. No, not available, because it's very also recent problem, this one. And if you can develop such kind of device, very ultra sensitive device that can be useful for on-site quick detection, that is very useful. You can start your own startup also. That also very important in this current scenario. So something like this, you have to think what is the main current problem. So that's why it is very much interesting. If you can study and you can address those problems, and you can develop some point of care testing device. That is very important if you can do. This is the, see, I'm just giving you some problem. This is very generic problem. So later I will teach you some sensor technology, how you can develop the sensor. See, I'm now telling you the story. I'm just motivating you, giving very general idea. Now, when I will teach you the development of the sensor step by step, so it can be useful for any kind of disease biomarker detection, and it can address these three problems. So that's why I'm just giving the story first. So you should understand first why we are going to learn this course. Now see, so this is the challenges, right? Now how we can solve this challenge? So as I mentioned, that development of sensor is not whatever I'm saying. Maybe you can think, oh, it's very simple. But for development of sensor, means solving all the issues, it is not very simple. So how we can solve these things? So we have to bring all the steps that I have mentioned. So if you think like a sensor, so you should have a transducer, right? This is a transducer. So what is transducer? That is a solid surface where we are immobilizing our bioreceptor, right? Suppose I will give you always the example, the bioreceptor is the antibody, right? Antibody is a bioreceptor. It can bind with a specific target, like some antigen, like some cancer, right? Like prostate specific antigen you want to detect. So this target is then posted specific antigen, and this antibody will be very much specific. It is a posted specific antigen, specific antibody. So you have to immobilize your antibody on the surface, right? And you have to drop your sample. Your sample should have some posted specific antigen. So it will bind then here. But your sample may contain with other analyte, other interfering species. What is the interfering species? Interfering species means, see, your sample contain posted specific antigen. Also, it contain other antigen, other antibody, other analyte. So they can hamper your electrochemical analysis. They can give the high background current. They can interfere your analysis, right? So those are called interfering species. So interfering species means other species that present in your sample except your target. That can't actually interfere your analysis. So you have to remove them to get the lower background current. So last class I taught you, right? Signal to background ratio should be very, very high. Then only you can achieve the ultra sensitivity, right? Can you remember, student?
Yes, sir. Sure.
Yes, sir.
So signal to background should be very, very high. So how you can get the high signal to background? So you have to decrease your background current and you have to increase your signal current. Then only you will get high signal to background ratio. So to remove the to get the lower background current, you have to remove all the interfering species present in your sample. So there is different way we can remove the interfering species so that we can get the lower background. So I will teach you step by step. Today I'm just giving a basic concept. When I will teach you actual sensing development technology, that time I will teach you step by step how we can remove the background, how we can decrease the background current, how we can get the lower background, how we can get the highest signal. That I will teach you slowly. But the first thing we have to keep in mind, to get the lower background, you have to remove or anyhow, not, it is not possible always 100%. You cannot remove always the interfering species, right? It is not possible. But we will try our best, always maximum how we can remove the interfering species. So one way is the washing. Washing means after adding the target, you can wash. How will you wash? You can use some buffer solution. Buffer. So buffer may contain some like PBS, phosphate buffer saline. It is one buffer. So buffer, it will contain some DI water plus some phosphate, sodium phosphate, this kind of some salt. So I think although this class is not for buffer, but I can give you some concept. What is the buffer solution? So buffer generally in the solution we are using some if you use sodium phosphate Na3PO4 or sodium Na2HPO4. So something like this salt mixture we'll use. So this salt will help you actually if you add very low amount of acid or base. So pH will be constant. pH will not be changed. So that's in your real analysis. Your pH must be maintained always. If your electrochemical signal during the measured electrochemical signal, if in the solution if pH change always time to time, then it can mislead you. Why you are getting signal due to the pH change or something else due to the change of the target concentration. So that can means that can mislead you. So pH change can be a huge factor. So that's why you always have to use some buffer solution in your electrochemical analysis so that your pH always should be maintained. So generally our blood pH around 7.2 to 7.4, our blood pH. So we like to maintain your electrochemical analysis this pH. So we'll use such kind of buffer like that, as I mentioned, phosphate buffer saline. We can maintain the pH around 7.2. And we can use this kind of buffer also for washing. But there is some other washing buffer available that I will let you know why we need different kind of washing buffer. Anyway, today you are very beginner, so I will not confused you. So the first, let's understand that we are using some solution for washing. Maybe it can be PBS, one kind of buffer. So after so after adding your target, so if you wash, so all the your not necessary one, I mean that is interfering one, so that they can be removed from the surface. Then you will get the lower background basically. So again, after removing these things, we may need again another antibody that is called secondary antibody, antibody 2, that can be conjugated with some nanoparticle NP. That I will again teach you, but just I'm giving you the story. Don't be confused. If you have any question, you can ask me. But let's understand the story behind this biosensor development. So first, we have to select a transducer. Then you have to immobilize a bioreceptor. Then you have to drop a target solution. Then you have to wash it to remove the unnecessary part. Then you can add a secondary antibody solution on the surface. That also will be very, very specific towards the target. It is kind of the sandwich assay. Why we need the secondary antibody? So that question can come right in your mind. So why you are using on extra step? Because this secondary antibody can help to generate a high signal. How? We can conjugate this secondary antibody with some nanoparticle, with some enzyme that may help to generate the high signal. See how? If you have the target, then only your secondary antibody that conjugated with some nanoparticle, they will bind. But if you don't have target, suppose, so this is your sensor is ready for detection. So what is this? This is your, this is, okay, let's open a new. I will teach you very clearly so that you can understand at least the basic first. So first I will teach you very slowly. Let's generate a new one. So please ask the question if you don't understand. So what is the basic part of the biosensor? Basic part of biosensor. See, first part is the transducer selection. That I will teach you again, how you can select the good material, because our class is the nano biosensor, right? Different kind of nanomaterial we will choose, different kind of metal we will choose. That I will teach you later. But first understand the story, that selection of the transducer. Okay. Second thing. Second, what you will do? On the transducer, you have to immobilize your bioreceptor. Right? So this is the sensor actually you need for the detection and for the commercialization. I mean, this is called your actually device that is ready to go to market for detection. Actually, people, end user, they're waiting for this part. But there is so many component that I will let you know. But the main generic part is this. The main basic part is this in the device. So in the device, this is the part where you can add your sample. So your third part is the detection part. So that end user will do, not you. So end user will get this part and they will drop the sample, right? So if sample contain the marker, then they will bind. But now think about the lab system, not the end user. Lab system. So let's say lab system, what maybe researcher, the technician, the laboratory. So what they are doing? So they are actually doing so many steps. What kind of steps? So after adding the target, they are washing. That is manual things, right? Not automatic. So after adding, you have to wash. was, right? So your interfering species that all are removed. This is third step. Now come to the fourth step. So fourth step after washing. So this is, so you need washing here. Then after washing, so you have target here. So after washing, you are going to add a mixture of solution that contain a secondary antibody, right? Antibody 2. So I'm just telling you only antibody like this. But this is just bioreceptor, right? You can change this one. Antibody to aptamer, some maybe DNA. It can be anything. That I told you already in my first class, right? Any kind of bioreceptor you can use. But always I'm just for example, I'm always saying antibody because very simple things and everyone you know what is the antibody, what is the structure. It is kind of the Y-shaped structure like this. You know the basic things, right? That's why I'm always saying antibody. Now, see, your antibody will be conjugated with some tag. This is the tag. Now you have to think what kind of tag you may need to get the higher signal. That you have to decide. So when I will teach you the technology development, so that time actually I will give you the more story. What kind of tag you can design? You can decide. So it can be some nanomaterial, some nanoparticle. It can be enzyme. It can be any kind of molecule that can help to signal generation. So basically, as I always saying, signal to background ratio is very much important factor for development of ultra-sensitive biosensor. So this tag will help now signal generation, right? So S will be high. And this third step washing will help to decrease the background, right? So like this, so you can go very high signal to background ratio. Okay, let's move. Now come to the very generic point, like just think it is a tag, any kind of tag. So this solution you have to add here in the fourth step. So you add it. Then secondary antibody, they will bind. They will bind secondary antibody like this. They will bind. Okay. So why they are binding on the surface? Because your solution, your sample solution, your sample solution that contain the target. If it contain target, then only secondary antibody they will bind. But when you are adding the sample, if it does not contain any target, I think you understand, right? What is the target? Target means that you are going to detect like some cancer antigen, right? Cancer antigen or some kind of any kind like malaria or dengue. So that you are going to detect. So your sample should have this marker. But if your solution don't have this marker, just think your solution don't have, right? Now, if you add this solution, secondary antibody solution that already tagged, then they will not bind. Antibody, I mean, actually, some study also there that we have to select those kind of antibody so that they should not bind here. Only if antigen present, then only they can bind on the surface, right? So if yes, tell me.
Sir, the secondary antibody will be same as the primary antibody, or it will be different?
Yes, that's what I'm saying. There is some other story also there that I'm not going to say right now because there will be other. Thus, I'm going to giving you the story for biosensor. That selection I will let you know later, right? Just think about that. This antibody will not bind here. There is some selection process. I mean, what kind of antibody we have to choose? Like all the selection process, I will teach you. Like the material antibody that I will teach you later. Just first understand the basic part of biosensor. Okay. Otherwise, you will be confused. There are so many steps. I am just going to teach you part by part. Okay. Okay, fine.
Yes.
Just think that you have one primary antibody and you have one secondary antibody. This secondary antibody will not bind with the primary antibody. So some antibody will choose. We have some specific antibody that are already available in the market. Also, we can produce also in animal model. We can produce some antibody. They will not bind with the primary antibody. Only if you have target, then only secondary antibody bind. So this is called sandwich assay. This is the sandwich assay they will form. So if you don't have, then as the secondary antibody not there in the surface, because of this tag, actually you are getting high signal. As this tag not present in the solution, then your signal will be low, right? Then you will get actually, so signal almost tends to like almost no signal. No, it means you will get only the background. So this is almost no. You will get only the background. So in this case, what happened? You can say this is the zero concentration. This is called your baseline of your biosensor. And this will help actually your detection limit. Your detection limit of your biosensor. I mean, zero actually your detection limit of your biosensor. But detection limit definition is something different that I will teach you later. Just I am teaching to the basic part. So what is the zero signal? If you are adding your sample and if your sample don't have the target, then you will get only the background current, right? This background current is your zero current, or your you can say that is your detection current you are getting. Now if you have if your sample content target, then this target will bind, right? Then your secondary antibody will bind that already has some tag. So from outside, so see, they inside lab, what we are doing inside lab, after adding secondary antibody, we have to again wash. So washing process needed. Why we need washing? Because we are adding many secondary antibodies that already conjugated with tag. So some of them, so suppose your sample contain only one target, one prostate specific antigen, right? But you are adding almost maybe 100 secondary antibody that conjugated with tag. So your one secondary antibody only on the surface, they already bind on tag and they form the sandwich. Other secondary antibody they may here, right? They may be randomly, they will be here and here, right? In the surface, correct?
Yes.
Yes.
So we have to remove them. Why we have to remove them? Because they may create the false signal, right? This tag actually helping signal generation. If they are present, so they may create some false signal. So you have to remove them. So for that you need again washing. So this is again one extra step you need, right? So this is the second time washing you need for the special. So I will teach you different kind of biosensor development. This is called the sandwich biosensor. Suppose, so after washing, what will happen? So so if you go the fifth step, so if you have one target, then after washing you will get this one. There is no other secondary antibody because they wash out. Suppose you have two samples, sample 1 and sample 2, 1 and 2. Sample 1 contain only one PSA marker, sample 2 it contain maybe five target. So then all 5 they can bind, right? They can bind 1, 2, 3. So I'm just drawing here one few antibodies, but generally thousand antibodies will be on the surface. So 1, 2, 3, 4, 5. So 5 target they bind. Then you will get again the 5 secondary antibody, right, on the surface. So then your number 1 and number 2, if you compare, so number 1 case you will maybe you are getting signal 1, but number 2 case you are getting signal 2. So which one will be the higher one, signal 1 or signal 2?
Signal 2.
So S2 will be much higher than S1 because you are getting so many secondary antibody they are already tag, and this tag actually helping for signal generation. That's why S2 will be much higher. That's why if your sample target concentration higher, much higher, then you will get the higher concentration. So based on level of the current, you can predict the concentration of the biomarker present in your unknown sample. That also I will teach you how we can calculate unknown sample target concentration. So for that we need some calibration, some curve, we need calibration curve, that I will teach you. But this is the fundamental steps first. So number 4 and number 5. So okay, let's remove this. The basic part of the sensor. Okay. So this is the number 4. You added the secondary antibody sandwich form. Then number 5. Number 5, what we'll do in the secondary antibody, you already have this tag. Now they should take part in some reaction, right? So that we will get some signal. So we have to add some chemical that is called like substrate. So we'll add some substrate that is very much specific with this tag, and they will react with this and they will form some product. So some chemical. Suppose if it is the glucose oxidase, this tag, suppose it is glucose oxidase. Glucose oxidase. It is kind of enzyme. So they can react with the. So we need some specific substrate for this. For glucose oxidase, specific substrate is glucose. So we can add some glucose. Then glucose will react with this glucose oxidase. It will form some product. And for this reaction, always this chemical reaction will produce some electron. That electron we can measure, and it will go through this transducer, and they can convert this chemical reaction with some signal. That signal you will get in your device, right? So number 5th step, there is some chemical reaction, right? This is chemical reaction part. In this chemical reaction, they will produce some electron. That electron basically will measure. So that is signal that we will measure. So if you have lots of this tag on the surface, then lots of substrate will react, lots of electron will be generated. You will get the higher signal. So this is the fundamental steps for the biosensor development. Clear, students? Otherwise, I will repeat. Please tell me if any steps is not clear. I will repeat. Please tell me fast. You have to understand first the basic part. Okay.
Yes, sir.
Clear, right?
Yes.
Okay,
Yes.
very good. Okay. Asin Tripathi. Asin, can you hear me?
Hello.
Yes, Asin.
Yes, sir. Hello.
What is your background, Asin?
Sir, biotechnology.
Biotechnology. I think that it is very good for you, right? You can understand the sensing development, right?
Yes, yes.
It is clear, right? Okay. Okay, fine. Let's come to the slide here. I'm just teaching you the lab 1 achieve now, right? So here I taught you that we have to overcome this kind of the challenges, and I taught you the sensor development in the lab. Right? Why I taught you like this way? I just wanted to show you the real picture of the lab, what we are doing inside the lab. So we are doing that. I taught you 1, 2, 3, 4, 5. So different steps we are doing in the lab, right? That is the lab environment. But if you want to develop a cheap lab, some device, end user, they can't do all the 5th step, right? For that, if they is depend man to man, it can vary. The reproducibility may change. So you will not get the exact result that you are expecting. So common people, they can't do like this. So this is a big problem. So for the device development, whatever we are doing, that is called the lab system. We have to bring all the system automatic way in the chip, on chip. So that's why it is called lab on a chip. All the lab work can be done on a chip. Now see, what is the lab work? That 1, 2, 3, 4, 5, this all the work is called the lab work. So for that, we may need sometimes sample purification. We may need sometimes sample amplification. Sometimes we may need some sample mixing. We may need some sample injection. These are all the steps we are doing inside lab, right? So sometimes see, we have to as I mentioned, like secondary antibody that conjugated with some tag. So we have to mix this one with your sample that should come to your chip. So this is kind of sample mixing you may need for the detection. Sample amplification, especially for the DNA-based biosensor. We may need sometimes the DNA concentration in our blood sample or in your real sample is very, very low. You may need to amplify them. So for that, we have to use some technology to amplify. But that technology I will teach you later. But some technology we have to use. Okay. So that method also you have to integrate to your chip. So that's why it is called lab on a chip. So what is the definition of lab on a chip? So if we can bring all your lab technology like purification, amplification, injection, mixing, separation, detection, all the technique can be included on your chip. See, there is a very simple picture here, like say there will be different holes and some channels, right? You can see here. So here you can put your some chemicals like glucose. Here you can put your secondary antibody that conjugates the glucose oxidase. Here you can add some any other extra chemical you may need for sample amplification, and this channel you may need for sample mixing. And at the end of your chip, there may be some point for your like working electrode, counter electrode, reference electrode, that is called your biosensor zone. This chip. So all the chemicals, everything will come to your sensor point. They will start reaction and they will give you signal. And for that, you have to insert your chip like this to your portable device like smartphone. So if you insert your device and all the reaction will be there on the chip, and you will get the result on your device. This is the whole story of the lab on a chip. So here also you can see a chip like this lab on a chip. Like there is different zone here, sample zone, like here the mixing zone. Then here you have detection zone. Here some discard, all the waste chemical and excess one, they can be stored here. This is the story. And this is the two things right now is very common available, glucometer and Penguin test meter. It is something like this lab on a chip. So end user, they're not doing anything, just they're dropping the sample, they're waiting, right? All the things, all the reaction, all the mixing things happening on inside the chip. So for the lab on a chip, that's why the integration is very, very important, right? How we'll integrate. That is the smart people who are very smart for the biosensor. They can do the smart work like this way. How we can design a sensor chip, how we can mix them together so that we can get higher signal to background ratio. So I will teach you slowly, step by step, different smart technology, how we can get all the steps like I taught you today, 5 steps that can be brought on the chip, and you can get the signal. See here. Now you may have a questions that why lab on a chip? Why not what's the importance of the lab on a chip? They have the very unique advantage. So if you make a lab on a chip, then you can easily miniaturize. You can make it very small. Like I think many of you already have seen the glucometer chip, very small kind of a Lego, this kind of a very small chip, and you are just dropping the sample here. We can easily miniaturize. We don't need basically large volume sample, maybe 10 to 50 microliter sample. Just a drop of blood is enough. Very low volume we need, low reagent we need, because inside the chip we can keep our all the reagent, all the antibodies, everything on chip. And because of the small size, we don't need the huge amount of the chemical. But if you go with lab analysis, they are using very costly and very huge amount, so it can increase the cost of your diagnosis. Automation. We don't want all the steps step by step manually, so automatically we can do by using some microfluidics. Just you have to start. There will be some maybe some here you can say some kind of automatic. I mean, you can use some pump. If you press it, then all the chemicals, they will go through the channel. They will start mixing. They will start reaction. They will go to the sensor area. I mean, everything will be automated. And also portability, the very good factor, lab on a chip case. I mean, you can easily make it portable. And it has, that I always mention, they have very important application, especially for medical diagnosis, environmental monitoring. Why environmental monitoring? I'm saying sometimes we have to go for field testing, like for nitrate sensing, organophosphate detection, or maybe if you see like some alcohol detection, like especially for traffic persons, they are checking the alcohol level, right? So it should be portable, and also it should be, sometimes we have to use for like field testing, right? Also environmental monitoring, as I'm saying, like for in the field or fertilizer, maybe sometimes we are using huge amount fartilizer or pesticide, so we have to tell the farmer don't use very high level of nitrogen level fertilizer. Sometimes farmer think let's use the high level, we may get the huge amount of product, right? We may get the I mean, it is maybe good for us. Actually, it is not good, because maybe your nitrogen level or your pesticide level can be increased in soil sample, and it can contaminate your drinking water, right? Also your fertility also of the soil also can be not that much high. Also it can be, there will be huge bad impact on the human, especially the nervous system, that can be affected because of the nitrate, high amount of nitrate can affect. So we can gives an awareness to the people also. That's why environmental monitoring, field testing also very important. And only portable, some lab on a chip device can help us. And for others also, yeah, I shall give some example. For drug screening, discovery, that all there also we can use from food safety, security. And as I mentioned here, lab on a chip has a huge market. If you have some idea, you can start your own startup also. So you can make your own plan here. So that is, you have a huge demand in this lab on a chip area. So I will show you now here some how the lab on a chip actually system work, how it working. Let's just, I taught you that lab on a chip means we may use some microfluidics, we should have some sample area, some mixing area, some detection area, right? I just wanted to show you some interesting video here. Just enjoy this one. Then I will still let you know again when how lab on a chip system actually works. Let's see. I think there is no sound here in this case. Just a minute. I think in this video there is no sound. So I'll show you step by step. While running the video, I'll show you step by step. So this is the lab on a chip. Like this is a chip, right? Now if you open the chip, see there is different component. This is, you are getting commercially, but it is not like this. It is like something like this. There is an inlet, the reaction chamber. See, here you are dropping your sample. Now it will sample the spreading, see, through the microfluidic channel. See, sample content, red blood cell, white blood cell, these things. So we can filter. Only analyte can pass through your lab, this lab on a chip technology through the C. All the cells are here, only the target that you want to detect. Now please come to the detection area. Oh, sorry. Let's start again. Try to understand the what is the mechanism inside the chip. See again. So we are adding, there is so many component inside the chip. When you are adding the sample, see, you don't want all the cells, so you can remove them by using a filter. So your filter is here, right? So you can use a filter here, right? So in this filter, you can remove all the cells, everything, all the blood cell, red blood cell, white blood cell. You may need some analyte that you want to detect, right? That is present in the plasma. In the you don't want the blood cells, so they are separated. See, now it is going to the now it is going to the reaction chamber. This area, all the chemicals here, all the antibody. So they all actually bind with some antibody, some that is with some secondary antibody, and primary antibody already coated on the reaction chamber. See, primary antibody coated. So if target present, then they will bind. So the sandwich will form, right? Clear? See, if target present, then only sandwich will form. See, so this is in this area, primary antibody already coated, and in the from the reaction, some another zone, we put some antibody that is conjugated with some nanoparticle with some enzyme. So they're also coming with your sample from the blood sample, and if target present, see everything will bind on your reaction area, and they will form the sandwich assay. Right now, you can press your substrate some chamber. Then substrate will come. They will start the reaction, and they will generate electron. And you can get the signal. Clear, guys? It's very interesting story actually. Lab on a chip, inside the chip. Hello, students.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. See some passing. It means so we are using the automatic washing. See, this is the automatic washing. So then we are not doing any manual things. We are not doing any manual. Automatic washing because we are using some flow, and also we can use some buffer solution. All the excess part they can wash out. So whatever we did inside lab manually, that can be done automatically inside a chip. This is the beauty of a lab on a chip technology. Okay. So I think I almost done 1 hour. Let's have a discussion with you. Then I will start again. See. So guys, do you have any questions up to now? Whatever I taught you, I'm teaching you very simply, slowly, and I can repeat if you have any questions. Then only I will go to the next topic. Is it okay? Everything fine?
Sir, I have a question, sir.
Yes. Who are you? What is your name? Anis.
From Biprodip.
Sorry, what is your name?
Biprodip.
Biprodip. Okay, please tell me.
Sir, as you said, the flow is sufficient for the washing, sir. Just one flow is sufficient for the washing.
Okay, that's a good question. Let's see. I will let you know. Here. Let's, I think, run the video again. Then. Yes, very good. Keep asking this kind of like this question. See, this is the chip, right? Let's I will stop it. See here. So this is, as you are saying, one flow is enough or not? So, oh, sorry. So here you can see we are using some inlet, right? Only one flow. But you are very true. Sometimes maybe we are using only 50 microliter or maybe 100 microliter sample, and that is flowing. So that is not sometimes not enough to wash all the samples. So that's why we have, if you get a high background, that's why you have to check first. What is your background level? If you are getting high background, what you will do? Then, okay, let's remove this. What you will do if you get the high background, right? And you have to design something different chip. So this is your chip. So last time they designed only one. So what you will do, you have to take one more inlet. This is one inlet. This is the second inlet. Huh? So then you have to connect them with this main connection, right? You can connect here. Okay, you can connect here with this. Then what will happen? Sorry. So you can connect here, right? So then after passing your sample, so suppose this is your reaction area, right? So you have the antibody here, and some secondary antibody you actually put here in this zone. So this is your target. Your secondary antibody is binding. But as you're saying, maybe first flow is not enough. Maybe still you have some interference species. Then what you'll do, you have to use your second inlet. So here you can drop some phosphate buffer saline. So then you can press, you have some automatic controller here. If you press it, then PBS will go through this one. Then it will, again, you may control. Maybe you can even, because it is the very cheap, only water sample, water solution, 100 microliter or 200 microliter. How much you want, you can flow. Then all the excess interference pieces can be removed and it will be stored in the waste chamber. Clear? Accordingly, you can design how many inlet you need for your chip. Clear?
Yes, sir. Clear, sir. Thank you.
Good. Any more questions? No. Okay. Let's start the next topic. Okay, now I will ask you the questions. See here, this slide. Currently available solution of the diabetes screening. So have you seen this kind of picture before? Guys, students, have you seen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. What is the left hand side? What is this? Do you know?
Glucometer.
Glucometer, sir. Glucometer.
The right hand side? Right hand side, this is also. Okay. So left hand side you can see is a glucometer, right? But you have to prick your finger, right? So why? How we can improve your technology, right? So suppose right now some people already develop glucometer, it has huge demand. But now you have a scope, you have an area I can give you. That area is, what is the problem? First you have to understand. Currently available solution is this, right? That is low cost. But what is the problem? Problem is the invasive. You always have to prick your finger. You drop the solution, and you can, so you see you have to prick first. You will have this sharp things, and you have to prick. You will get the blood, and you can get the result. So, but it is not you will not get the full solution from this technology. Why? Now think, the diabetic person, before the meal, they have to check the level of glucose, always. Also, just think, some developed countries, especially the babies who are child, they also have kind of diabetes. nowadays because of their lifestyle, these things. So nowadays, very, I mean, around after, I mean, you can say within 1 year or 2 years, if you check their level also, the glucose level, that is also very high. That is the, I mean, that is also one technology that we want to develop. Sometimes we may need to detect their glucose level also, like baby case. But it is very difficult to prick their finger specifically. Just can you prick their finger always before their meal? That, I mean, within a day, you know how many times they are drinking or they're taking the foods. But can you prick their fingers always? So it is very difficult actually. So that's why this is the problem currently you have. How we can solve this? Also, not only the baby, also you can. This is the exactly the true for adult case also. We cannot prick our finger always before the meal. So that's why we have to solve this issue. So if anyhow, if we can make some non-invasive, maybe from your interstitial fluid, from the sweat, if we can detect the glucose level, and if you can give us the information, yes, this is this much level glucose you have, then maybe you can go for the insulin treatment. Or if you see that yes, your glucose level fine, then you can go for your meal. Some solutions there, some portable things, like a patch kind of things you can put on a skin, and some smartwatch kind of things also available. But if you see left hand on, they're cheap, you can dispose after use. But this kind of things, they're expensive, you can't dispose after use. They're very expensive things. So then that's why if you can make a non-invasive thing, non-invasive monitoring, glucose monitoring system, at the same time, if you can make the disposable one. Disposable means just one time you can use and throw. I mean, it is very cheap system, not expensive thing. Then it can be a solution. And so means this area you can focus also, one area. But why we need the continuous glucose monitoring, right? So you should know this one. What is the continuous glucose monitoring? As I mentioned the story, especially for sports persons or especially for diabetic persons, we should know the level of the glucose always. Otherwise, it may create a big problem for their health. So I just wanted to show you a video that what is the monitoring of glucose and why actually we need this continuous monitoring. Let's see this video. I will show you. The continuous glucose monitoring.
What is continuous glucose monitoring? CGM. You may be wondering.
Okay, let's see.
You may be wondering, what is continuous glucose monitoring, or CGM? In the next couple of minutes, we will explain what CGM is and what it can do for you. We will also introduce you to the various parts of the Guardian Connect system and let you know what you can expect when using CGM. Your glucose value constantly changes, going up and down depending on many factors, such as food, insulin, and exercise. And up until now, you have used your blood glucose meter to tell you what your glucose value is. However, your meter can only tell you what your glucose is for that moment. What if there was another way to get information about your glucose levels? Well, CGM gives you a way to see what your glucose levels are throughout the day and night. A transmitter and a monitor. The sensor is inserted under the skin, so it is in contact with the fluid between your cells, called interstitial fluid. The transmitter is connected to the sensor. The sensor then measures the glucose in the interstitial fluid and sends this information to the transmitter. The transmitter then wirelessly sends this data out to your device. Glucose is always moving between the blood and interstitial fluid. BG meters measure glucose levels in the blood, and sensors measure glucose levels in the interstitial fluid. This is why meter readings and glucose readings from your sensor will rarely be exactly.
Yes, that's like the thoric. We always have to compare the BG and blood glucose and the interstitial fluid glucose. The technology we are going to develop, that is from the skin, right? Skin means you can't go up to blood. You can check from the just below the, here it is the interstitial fluid there. Means your always glucose level in blood is very, very high than the interstitial fluid. But we can correlate. Based on the level of the glucose in the interstitial fluid, we can correlate what is the normal concentration and what is the diabetic level concentration. That we can correlate basically. That we will have the information. Anyway, that is not a big issue. But for comparison purpose, always we are detecting the level of the glucose from interstitial fluid, also the blood. Then we are comparing. Then we can say, yes, how much accurate your device. So blood level glucose always, this is the standard one. So whenever you will develop some very smart technology, so smart technology means you have to depend on your some other biosample, right? Like saliva sample, like urine sample, or like sweat sample. But always you have to compare with the blood sample. And if you can correlate with them very good way, very effectively, then your sensor is very good. Let's see again.
The same. This difference between BG and SG is okay and should be expected. Let's see how a roller coaster can help illustrate this. Picture your blood glucose and sensor glucose as cars on a roller coaster. The front car will be your BG and the back car will be your sensor glucose, or SG. As the roller coaster starts up the hill, you can see that the BG in the front car is leading the SG in the back car, and the numbers are different. As the cars head down the hill, or as glucose is trending down, you can see the numbers are still different. Most often, the BG and SG numbers will be close to each other. However, you'll see a greater difference in BG and SG on the bigger hills, or when glucose is changing more rapidly. For example, after food, after insulin, and after exercise. When you use CGM, the focus is not on the individual number, but on the trends, since your glucose constantly changes. Is your glucose rising slowly, or is it falling rapidly? Your CGM system can alert you on your high and low glucose values and show you the speed and direction that your glucose levels are moving, giving you time to take action if needed. Keep in mind, CGM does not replace BG meter readings. BG readings are still needed to keep your CGM system working properly. It is also necessary to confirm your sensor glucose with a BG reading before making any treatment decisions, such as giving insulin for a high BG or treating a low. CGM is a tool that can give you insight to how your glucose levels change throughout the day and night. Expect that it will take a little while before you feel comfortable with this technology and know how to use the information you're receiving. Between your healthcare professional and Medtronic, you will have the help you need along the way.
Okay, so this is the story. That's why we may need to develop something new technology for the glucose monitoring. See, now I will teach you something new technology that is called lab on PCB. How we can monitor the glucose without pricking the finger in non-invasive way. So for this, we can depend on some different technology. First thing that I want to show you one new thing, that is a printed circuit board. PCB means printed circuit board. Recently, actually, we are focusing the integration of our biosensor technology with the printed circuit board. I think you are already familiar with the printed circuit board. If you open your computer, your electronic device, mobile, I think you have seen already, right? This kind of PCB, have you seen the circuit, this thing? This is the printed circuit board. Student, have you seen?
Yes, sir.
So they are the PCBs. So, and why I'm showing you PCB? Because they're very cheap. I mean, very easily we can fabricate. We can get it. I mean, this is very good for low cost fabrication, low cost device development. PCB is very good for this. So we can use this PCB for biosensor development. If you see this kind of so many channels, these things we can easily fabricate. We can use them for our sensor. See here, right hand side, this one. So this one you can see here I put kind of this. So this is on the PCBs. You can see some WE means working electrode, C means counter electrode, RE means reference electrode. So all the electrode we can fabricate on the PCB. And you can see this channel. This is called the microfluidic channel, right? We can integrate the microfluidic channel on the PCBs. So this is the connection part. We can connect with your mobile device. So everything there. So your PCB actually helping to form your whole device, biosensor device. So you can inject your solution. So they can come through this. So they can mix all the sample. Then they will come to your working area, means where you actually immobilize your antibody. Working electrode means your transducer, right? Working electrode means your transducer, your antibody there, right? So now you can, you can manage your sensor based on your method, which one you want to develop. So it means if you want one more inlet, you can add here one more inlet. If you need two more, so you can add two more inlet based on your technology. You can add, you can change. So why that's the my main focus to show you why I choose the PCB, because easily we can fabricate. We have very established fabrication method, not only the worldwide, all over India, even your local market also you will get this thing, fabrication method. You will get it. And in a large scale you can make. When you will go from small scale to large scale, then cost, basically as you are thinking the affordability, the cost of the sensor will decrease. Cost will decrease. This is the thing. And also you can see the layer 1, layer 2, layer 3. I mean, even we can add so many layer here on this PCB based on your requirement. You may need so many chemicals, right? So layer by layer you can add, so you can use them for storing your chemical. Maybe you may need some heater. You may need to heat your sample, right? So in this case, maybe you can use here some circuit that can help to increase the temperature inside this microfluidic solution. I mean, it's up to you. Whatever you need, you can design. So I'm just giving you the idea, then you can think. So I will give you some project. So you can think. So at the end of this class, so not today's class, end of this our course, I will take you one presentation. On that day, you can freely think, you can present your idea. So based on that, I will also give you some mark. See here.
So like these layers, are they like stacked one above the other, or
right. Stacked one of each other.
Okay.
We can make it. We can stack each one of other. See here, actually, I show you one thing. See, sometimes just in this case, as I mentioned, that you have to inject your solution. But I told you how we can develop a patch kind of thing, right? This is the patch. So we can like flexible substrate. So your PCB should be then flexible, not the hard one, right? So you have to print all the things, your PCBs on a flexible substrate, right? So based on your requirement, you can think about the material of your sensor surface. So here, see, some patch kind of things. Then your sensor will be like flexible substrate. This is the patch, flexible substrate. And here, so see, I use some hydro. But it is also painful, no. So we can make very small, that will not hurt your nervous system, only on your upper skin, and it can absorb the interstitial fluid. And this fluid now, I mean, they can absorb in this region. Then they will collect all the interstitial fluid. Then it will go through the channel. Then it will come the working electrode, counter electrode, reference electrode we fabricate here. Then excess one it will store here. So something like this we can design. And we can detect different concentration of glucose. See, you can see in the left hand side, this is kind of the calibration curve. So we just increase the glucose and we are getting higher and higher and higher the current. If we increase the glucose, we are getting higher and higher the current, right? Then we will get a calibration like this. What is the calibration? Again, I will teach you about this factor, everything. I will teach you. That I'm giving the basic story here. How we can create a calibration. That I will let you know. So see, here I am using one term. This is a bench to bedside lab on a PCB. So this you will be familiar slowly with this term. Bench means, what is bench? Bench means it is the lab. Bedside means it is the near patient, right? On site or bedside. So we are bringing our technology from lab to, you can say lab to market or lab to near patient. So basically, this is the PCBs, one kind of PCB. This is another kind of PCB. So we can say we can fabricate like this different kind of design. You can think like circle type, semicircle type. Maybe we can make some hole. Maybe we can, this can be the inlet. This can be the outlet. We can design according to your needs. So in this case, we may not need some microfluidics, but in this case, we may need some microfluidics, right? We can, accordingly, we can design. It's something we can, not only the electrode, maybe we have to generate some cathode and anode, or maybe some fuel cell. Some fuel cell. For fuel cell, we have to create some cathode and anode. So they can generate the power also. You may not need extra energy from outside. It can generate its own power and it can supply to your sensor. So it is called cell power biosensor. See, in some African countries, I have seen some stories there that some villages, they don't have, they don't have any electricity. Then how they will run this kind of biosensor? So what they can do, we can create some biofuel cell. This is called biofuel cell. Biofuel cell. They can generate the power from glucose, right? As I mentioned, we are detecting glucose. So your sample contain glucose. So that glucose can oxidize and it can create the power. It can generate the power. That power can be used for sensor activity, like for generation, for the signal, these things, they can use this power. That is called cell power biosensor. So that is also another technology you can develop. See, like this way, cell power biosensor device, like a patch device, something like the Band-Aid, like this. There is a button. If you press it, it will start working, and it will take, from the interstitial fluid, because it contains glucose. So there may be one cathode and one anode. So here glucose can oxidize in the anode, and cathode, maybe some oxygen can be reduced here, and it will produce an electron, and that we can actually mathematically we have to calculate how many you need cathode anode, because only very few very small amount current you can generate from a single chip. Maybe you can integrate few chips together. Chip means like this, maybe here 1 2 3 4 together. Maybe you can generate 16 17 or 18 like this. You can integrate together and you can create a maximum amount of energy to run this sensor. Then now the biosensor may start working, and then it will send its information through the Bluetooth to your mobile device. This is the smart technology we can develop. Here actually, this is actually I want to show you one result that while I was in Michigan State University, actually I was there That time I was working with him, and he went actually to the of Malawi in Africa, and we developed something like this microfluidic integrated biosensor. You can see here. Actually, we developed that time when I was in Michigan State University. That time we developed a inlet 1, inlet 2. So here we use some sample. I think very good question. I think I forgot your name. One of students you asked me today. Just maybe we can use some another channel for running some buffer so they can wash out all the excess part. And excess part can be stored here or maybe here. And this is the biosensor part here. You can see the working reference counter, and this part we can integrate with some electronic part. Definitely we need to amplify the signal. This is the electronic part. So electrical engineers, they are very smart. They can amplify this very small amount of the electron they're passing, although they can amplify. You can use some app in your mobile phone and you can detect. So you can see that this is the real picture. And this is the smartphone with some cable. We are connecting with this sensor and we are detecting the malaria we detected in Malawi. So this kind of scope you have, and this is very small. You see the chip size. It is kind of sorry. You can see it's kind of like your mobile phone SIM card, right? It's very small. So it is miniaturized device that you can develop. So that I actually wanted to show you some real picture that I developed in our lab. So here, this is a kind of small sensors here you can see, like working electrode, counter electrode, reference electrode. So on the working electrode, we actually conjugated all the primary antibodies. And I think some of students today just asked me that we can put all the things stacked and layer by layer, step by step, like this. This is kind of the paper, their paper. So on paper, we can keep some reagent in dry form. One by one, we can keep on the chip. Now, when you drop the sample, like blood, urine, or sweat, they'll come through all the reagent. All the reagent will dissolve. They'll come to the channel here. And sometime here we may not need the washing. So we can generate some washing free biosensor also. But how we can without, this is the without microfluidics you can see here. So we are using here different chemical like ascorbic oxidase. This is the antibodies, 2 antibodies. Some chemicals, they will help to generate the signals. So without microfluidics, we generate a chip for malaria detection. That's why it is called the wash-free biosensor. But what is the technology that I will teach you later, not today. Today I'm just showing you how, there is some scope you have. We can develop some wash method, but for that maybe we have to integrate the microfluidic. Sometimes we can develop some biosensor without washing also. We may not need also microfluidics. That is called wash-free biosensor. That also possible like this way. But what's the technology behind this? I will teach you later. Just learn the scope first. So what is the future prospects? So here you can see. So if you have the full knowledge of the biosensor, so during your project, your fourth semester, I think your fourth year project, if maybe you have to do some fourth year project about the undergrad students, who are the master students here, maybe some of during your course curriculum, maybe you have to finish some project work. You may think some area here. You have some future prospects here, like you can develop some portable device using some washing free method, some smartphone based method, some printed method, some lab on a chip method, lab on a PCB method, some wearable sensors we can develop. Different area still you can explore. Also, as I mentioned, you can generate some self-power biosensor that is called a biofuel cell. You can develop, like one is the one area glucose can be oxidized, one area oxygen can be reduced. So oxidation and reduction happen simultaneously. So anode and cathode you can generate, and you can develop a fuel cell basically. That is called biofuel cell. and some algorithm mathematical this thing. I think electrical engineer, they are very familiar with this. So I'm not teaching this part anyway. So this is something we need. As I mentioned, that our sensor basically is very much interdisciplinary area. So one part is the sensor that I'm going to teaching, but still some electrical engineer, they may think how we can amplify the signal. They know how to design the circuit. So for that, we have to collaborate with the electrical engineer people. They can amplify although you are getting very low amount of electron, but they can amplify it, and you can see the output. So this line, I like it very much. Whenever I'm teaching my students, always I'm showing this line. Just read it. I think this is my motto in my class, in this class, that breakthrough discoveries cannot change the world if they do not leave the lab. This is my motto actually, and I like it. That always, specifically in this course, so you have to do something. So don't only for in your lab, not for the publication, right? So that you can bring your technology, your science to the market. So the end user, common people, they can use. So that you can use for mankind, right? So this is these things. I mean, this technology basically will help you how you can bring your technology to the market. That's why I'm saying lab to market or bench to bedside. This thing. Okay. I think as I am teaching you, this is very beginning, just two, 3 classes. So I will not give you too much load to you. So at first you should understand the technology. Then I will go to the next step. I think today I taught you so many things. At the beginning, I will go a little slow so that you can understand the biosensor, what is this, how they are working. And I will not give you too much load so that you can understand the basic part first. Then slowly, when I will teach you that technology part, how we can develop the sensor, that I will go a little bit faster. I think, is it enough for you today? Do you have any questions, guys?
So I'm having a question. So,
Yes, please.
So this is Anish.
Yes, Anish, tell me.
Yes, sir. So when we were discussing about CGM, so that was a non-invasive technique, right? So while blood glucose in glucometer, that is an invasive technique. But like after the video, we saw that CGM, through CGM, we are getting both the readings of the sensory glucose as well as the blood glucose. So like how we are inserting the chip just under the skin, right? So how we are also getting the reading of the blood glucose from them? I got confused.
See, that's in that video they already mentioned that you were already checking here this slide that I am just showing, that we are measuring the interstitial fluid glucose, right? So this is the non-invasive method. But what generally we are doing? We are doing a mathematical algorithm or something like this, that your sensor, like not this one, this is the developed method, like this is the non-invasive method you are developing. So you have to get all the data, like you are making a calibration curve, right? Then you have to compare this one, not at the same time, but during the lab experiment, you have to compare this data with the blood glucose level always. Like you are detecting, like patient to patient, it can vary. That data also you have to check, and you have to make some algorithm or some mathematical modeling you have to do. So that we will do inside the lab, and that data we can put on this app. They will give you the proper guidance on that time, because we already monitored the blood glucose level and we already monitored the interstitial fluid glucose level, and we correlated them, and we made a mathematical model, and that information already will be included with this app, and they will guide you properly. So it means, although you are monitoring the interstitial fluid glucose, but actually you are correlating, you are getting information from blood glucose also. So inside lab, actually we are doing this test, but you don't have to do all the blood test. You have to do
so
only
it comes like inbuilt already.
Yes,
Yeah.
you will do only the on-skin test. I mean the interstitial fluid test you will get.
Yes.
But developer people, they will do the mathematical algorithm, they will do the modeling, that they directly have to correlate with the blood glucose, and that information you will get from the app. So although indirect, I mean, you are getting actually information indirectly, blood level also you are getting indirectly. So they will give the advice based on the blood glucose also.
But certain the algorithm has to be standardized enough so that just
yes, lots of work need to be done there. So it is not very simple things, but you will get very simple things in your hand. Everything can be done inside the lab. That's why we're saying this is the lab on a chip, but many works need to be done. That's why next class I will teach you translational health research. Today I don't want to show you again because it will be too much load today. So many things I taught already. So translational health research means there is so many steps like T1, T2, T3, T4. I think some of you know already. For development kind, if you want to solve any one problem, it may take almost 10 to 15 years. Then only you are getting one product, one vaccine, one medicine in the market. But behind this, you are getting very simple medicine, just you're taking and problem solved. But behind this medicine, behind this vaccine, behind this device, there is a long story that we have to face. That engineer people, the scientists that we are handling inside the lab, right?
Sure, sir. Yes. Okay. Thank you, sir.
Yes. Okay. Any more questions?
Yes, sir.
Tell me. So I want to take the your attendance download. I'm downloading. At the end of my class, I will attend your. I will download your attendance. And one thing, so as I mentioned that today 44 students are here. It's very good. Attendance is very important. I will regularly check. After a month, I will update you. If some of you are not regularly coming, then I will request you to deregister this class, because otherwise it is very difficult to understand, because I want to give my best so that you can understand this class. But if you don't come regularly in this class, then I think it is bad for you, because you will not see whoever absent today. So next class when I will teach you the translational health research, they cannot understand, right? Are you agree with me? There's so many things I taught you today, right? So many things. So if you miss one class, you will miss so many things, because this is very interdisciplinary course. If you miss one class, you will miss so many things. But still, we are recording the class. If sometime because of some unavoidable reason, maybe you may not be there in the class, it's fine. But please try to attend more than 80%. Maybe after a month, I will update you. If you are not present more than 80%, then I will request you please please deregister end of this course, and I will take the exam after a month. So total 3 class tests and 1 presentation will be there. And if you cooperate with me, definitely I think you see my teaching style, everything, definitely you will get the good grade. I think it will be clear in the classroom also, it will be very clear to you. But because it is kind of the research oriented also, because I am also giving you input of the currently the research going on in this area. So I will show you how to search the papers, journal papers. So once you have some time, you can search in Google some research, recent research in this area. You can read some journal papers also. And if you have any questions, if some part is not clear to you, you can ask me during the class. Not only in only these syllabus things, you can ask me the out of syllabus also. Maybe I can arrange some special class for you, because you can see in ERP this class only for Wednesday. But I was thinking if you can make this other time, not only the Wednesday. But there are so many students here, it is very difficult to manage the time. If I say Tuesday, then almost 10 students will raise the hand, I am not available Tuesday, right? Tuesday 8 to 9 a.m. not available. If 6 to 7 p.m. not available, I will get the 10 hands already. So that's why I'm planning maybe from the next year, maybe if you can make this time schedule in ERP itself. So please check the timetable, then register, right? That is the better. But you already registered for this class. So let's continue this class on Wednesday, at least 3 hours. But although it is difficult, I understand. But we'll have some fun. You can take some break. You can go for breaks now. Then you can start again. But for beginning, I'll go a little slow. Around 2 hours or 2.5 hours, I think I will teach you, or maybe 1.5 hours if you are very tired. But you should understand the basic technology. Yes. Do you have any questions?
Sir, sir, for wash-free biosensor, how the requirement of decreasing the background signal that we usually do by washing is met?
Yes, that is that. I mean, that technology I have to teach you, right? Today, actually, I taught you. Today, I taught you the scope. This area you can explore, right? Now, now I will teach you step by step how you can immobilize antibody. I will enter, right? So this is a very advanced level. You are asking the question. That advanced level, I think, after a month, I will teach you. That definitely, this is a good question. You will get your answer.
Okay, sir. Thank you.
You will get your answer definitely. Because it is already included in my syllabus, was free, and it is the very important topic. I will teach you the technology. You should try it in your future also. Was free technology can solve many problems so that you can develop your device, because you always need washing to remove the unwanted things. Okay, good. Any more questions? No.
Yes, sir.
Yes. Ask me.
Sir, regarding CGM, I want to ask that in which part of the body it should be attached? Is there any specific part where we can get good result?
See, currently, so we're thinking just on skin. We're not, because they will collect the interstitial fluid, right? So we don't have any. We don't think any kind of specific part only they can be applicable. Maybe you can put it on your arm or abdomen. Some places you can add, but generally user friendly. That is, you can put it on your arm, that place. But still some research going on. You may think maybe some. When I'm saying today, tomorrow you can see some group. They published a work. This place interstitial fluid give the better result. This is fully research area. As I'm saying, this is a very modern topic. So maybe tomorrow, maybe some group can publish some work. This area is very accessible for this. It is possible. Maybe in your future you can try. But right now, until now, I can say yes, no. You can try. I mean, in your arm, or I mean, there is no specific place for this.
Okay, sir. Thank you.
Sir, can we have next 2 hours class on Saturday?
Sorry.
Sir, actually, we had filled Excel sheet as you had instructed in previous class, in last class, and we found that on Saturday everybody is available. So, will it be possible for class?
That's why I'm planning, but I heard that some students that are final year, they have their replacement again this Saturday. So many of I know in this class many students from the final year. So that's the problem. That's why I'm just trying. I think this is a very far. Just you are the beginner here in this class. So I think first I will teach you around 2 hours and 2.5 hours. Then slowly I will teach you around 3 hours. But I know this is too much for you. One day for 3 hours, right? But I will cover the whole syllabus, and I can take some special class. Basically, I prefer Saturday. I may take some special class, but if you are okay, maybe I can arrange any time based on your preference. But let's start first. Every Saturday, every Wednesday first. I will cover maximum syllabus. If you think that no, it's not covered fully, but I have the experience from my previous classes. I can cover within. If I teach you also 3 hours or 2.5 hours, still I can cover maximum the syllabus. But definitely I will take some extra class because currently we are doing the online class, but there is some tutorial, some lab course, I mean lab based some work there. but currently you are not in campus. But while you are at the campus, you can contact me. I can show you some experimental part in my lab that we are developing. But from future onward, while all the students will be here, generally I used to show them some lab work also. That's why I included 310. So some lab-based things also included, but currently it's not possible. Or maybe I can arrange some video, something conference kind of things. I can show you my lab facilities, how we are generating, how we are developing the sensor. Maybe one day I can show you over the video, right? That may work, right? Is it okay?
Surely, sir. It will be a lot more beneficial for us.
That would be great.
Yes, actually, that I used to do. Generally, I'm just inviting my students, just come to lab, like 50 students every, 20 or 15 students at a time I can call, and you can see all the facilities. Also, even you can handle the facilities also. You can fabricate the antibodies, nanomaterial on the sensor chip. You can see what is the lab on a chip, what is the lab on PCB, right? You can see. Anyway, I will show you one day. The real video I will show you one day. You can see all the facilities. Currently, let's see. Every Wednesday, 2 to 3 hours, I will teach you. Around 2 and 2.5 hours. And hope I will cover all the syllabus. And also, I will arrange some special class also for you. And also, if it is not clear to you, you can personally, you can email me. Maybe I can arrange, maybe if you have like 10 students, like 15 students together, maybe if this topic is not clear, like for the 10 students, maybe I can arrange a special class for these 15 students also. It's not like this that I have to invite only all the students. Maybe you can, maybe some of you, like Ocean can understand. So Ocean, you don't need to present in this class. Maybe if you don't understand somebody, you should be there. I can arrange some special class. I like to interact with you always. It's fine. Ananya Sharma.
Yes, sir.
So is it okay? Everything fine?
Yes, sir. Yes, sir.
Good.
Hello, sir. Please. Hello, sir.
Yes,
This is
Achilles. Achilles, tell
sir.
me.
Actually, yesterday are you calling me for third semester project?
Okay, that is for your triple M project, right? That I will discuss you separately, right?
Okay, sir.
Okay, fine. Okay, I already took your attendance. Okay, that's all. Thank you very much. We'll see you next week again.
Thank you, sir.
Thank you, sir.
Okay, please be.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.